Good morning, everyone. My name is Chris Witham. I'm with the Oriental Motor Tech Support. Hopefully all of you can see and hear me right now. If you have any questions throughout the seminar, there is a desktop area for you on the left-hand side of the screen to enter any type of message. Feel free to type any questions that you have as we go along through the presentation, and I will address them as they come up through the presentation. So today we're going to go over AC motors. This is going to go over some brief theory and then some product information as far as what products we have to offer here at Oriental Motor. So with that, let's begin. The types of AC motors. There are a lot of different types of AC motors out there on the market. For example, here's the shaded pole. This is for a low starting torque for cost and a lower efficiency with no capacitor. The PSC type, which is a permanent split capacitor, this is have moderate starting torque, more efficiency, and it uses a capacitor at all times for both startup and operation. We also have the split phase, which is low to moderate starting torque, no capacitor, and it starts, switch drops out around 75% of the operating speed. We have a capacitor start, which is exactly how it sounds. A high starting torque uses a start capacitor, and then switch drops out at around 75% of the operating speed. Then we also have the capacitor start and capacitor run. Again, similar to capacitor start with the run feature. Oriental Motor, for their AC motors that we manufacture, we manufacture and make the PSC type, this permanent split capacitor. This is going to allow us to have the highest amount of efficiency. It is going to allow for a moderate starting torque, but then it's also going to require that a capacitor is used at all times for both startup and operation of that. This is kind of a breakdown of our motor construction here. It's made up of 4 components for our AC motors, okay? The first component right here, this is the motor case here, which is made from a die-cast aluminum. The cast is machined inside to allow for the assembly. Okay. The second component here, the stator, it's made from laminated silicone steel plates. It's got copper coils and insulation film inside. Then the third component, which is actually made up of 2 components, we have the shaft, which is in this area here, obviously, and then bearings. We have the bearings on both the front and rear of the rotor. The rotor is made from like a laminated silicone and steel plates with die-cast bars aluminum through them, and it's supported by the 2 bearings, the front and the rear. This rear bearing right here is going to fit in the rear end of the motor case, while this one up towards the front is going to go into the inside flange bracket, and the flange bracket being our 4th component of our motor construction. All the components that you see here, when we assemble them, they are assembled as a press fit. So there are no screws or anything like that. Oriental Motor uses the press fit design for 2 reasons. One is ease of construction. It's just easier not to have to deal with the screws, and maintain the quality is easier. The second one is if we are to use screws to hold the flange bracket on, the rotor could skew, and then the screws were torqued at different values. It can throw off the performance of the motor and throw off the quality. So that helps us maintain our quality, and it allows for easier manufacturing. So the rotor construction itself, if we take a look, this here is a picture of our actual rotor. The rotor that we have here is laminated silicone steel plates. These plates are stacked, they're on top of each other, and then they're slightly skewed or slightly offset of each other. Okay, and then they're pressed together. What you'll see here is these areas here going along here is the molten aluminum that's poured into the notches. Okay, so this is what the top part of the plate looks like here. This is all the plate, and then it's slightly set, and then the molten aluminum is poured down. So if the bars were straight up and down, the motor could slowly start moving until the bar caught up to the current. But by skewing the bars during manufacturing, a portion will always be positioned so that like the phase immediately induces a current on the rotor, and the starting torque doesn't depend on the rotor position then. And then we look at voltage versus torque. Okay, voltage and torque. The output torque of a motor is dependent on the voltage. The relationship of torque to voltage is almost proportional to the applied voltage that you're taking to the motor. So if we increase the voltage, we're going to also increase the torque. With that in mind, though, we have something that comes across is going to then be is the heat is going to increase as we increase the voltage. So if we look here at speed RPM on our x-axis, and we have our torque up here on our y-axis. So starting at 0, we move to 500 RPM. Our torque increases at, let's see, 103 volts. It sits around here right above about 100, about around 15 ounce inches. So about 15 ounce inches of torque. If we increase the voltage going up, we're increasing our torque along with our speed. Again, this is going to cause a situation of to where we do like more torque and more speed. The voltage is going to rise and cause more heat buildup in the motor. Now, with heat buildup, you can damage the windings. Now, when we take a look at heat, thermal considerations we need to look at is the actual case temperature of the motor. Okay, the motor that we have here, we try to keep the case of them to around 100 degrees C or less. So when in any type of conditions, you want to also consider your ambient temperature range. So if you're in a real hot factory or something like that, along with ambient temperature, there's also going to be the thermal consideration of the motor's heat generation as well too. So we want to try and keep this heat reduced. All of our standard induction motors are rated for a Class B insulation, which can withstand temperatures of 130 degrees C on the windings. So that's equivalent to 100 degrees C on the case. So if the case reaches 100 degrees C, it's pretty close to that the winding is going to be around 130 degrees C, which is very potential for big potential for danger on the windings. Now, overheat protection, we do offer something to help protect our motors. All of our standard AC motors have temperature protection. The smaller motors that we have, a 1 watt to a 6 watt, they're impedance protected. Okay, these are real small size motors. So as the temperature rises, the winding resistance will increase. So when the resistance increases, the current reduces. Okay. Basically, a reduction of performance is then going to be seen. The motor's not going to have enough power to continue turning, so it's going to basically start slowing down and then suddenly just start coming to a halt. Once the heat dissipates, the motor will be able to start back up and resume rotating. Our larger motors, basically from the 15 watt up, they're going to have our thermal protection unit. Okay, this is kind of a breakdown of what it looks like inside. We have a bimetal here that comes down to this piece, and the thermal protector has that strip in there. The two metals have different expansion coefficients, and when the temperature reaches a certain point, like 130 degrees C, the metal separates and creates an open circuit, so it shuts the motor off. So this is a normally closed circuit. When the heat gets too high, it will separate and shuts the motor off. Once again the heat is dissipated, the motor will then resume back to its original operation. If the temperature is too high, we do offer different ways to help counteract that. One way is to reduce the duty cycle. If you're running all day, every day on the motor, if you can, if there's any time in between where the motor can just sit and help dissipate heat, that's a good thing to do. Very popular thing to do is mount a heat sink to the motor and also to paint the heat sink black. And in some cases, it may be required to cool them with a fan, like if they're in an electrical cabinet or in smaller, tighter areas, fans can be used to help circulate and dissipate heat. Reduced heat can improve motor life. Basically, what we're worried about with the heat is not only the heat on the windings. We don't want any damage to happen to the winding, but we also don't want any damage to happen to the bearing. Heat is a big killer of bearing life, so we don't want the grease to separate and destroy any type of the bearings that are inside. So moving along, the next thing we're going to talk about is just our AC motor products. Now we have a couple of different series that we talk about. If any of you have a catalog, you may have noticed we have the World K series, the V series, the VHI series. All these are different standard induction motors and reversible motors. When we look at this, we're going to look at basically the global standard. 3 voltage options are shown. By having these wide range voltages, we can ensure that the motors are capable of operating throughout basically different parts of the world. It's possible that a different capacitor may be necessary for each one, but that's easier than having to change the whole motor. Induction motors that we have here, we have basically a 1 to 200 watt motor. They're bidirectional, so the motor can rotate in clockwise, counterclockwise directions. However, it does require that you come to a stop first. After that, you can then switch the direction by either a switch or switching the leads on the capacitor, and then you can run this all day. It's rated for a continuous duty, has a long life. The one thing you want to be careful of is overrun. At any time, if you're stopping like on a conveyor or a lead screw, you will have 30 to 40 revolutions of overrun on the motor. This is without a gear head, and this is without a load. So from the time you pull voltage away from the motor will still continue to run for around 30 to 40 revolutions. Okay. Different applications that we've used these induction motors for, different pumps, film developing copy machines, labelers, and slot machines and vending machines, different types of thing where just a continuous motor speed is needed. Going over basic part number structure, this is a lot less complicated than it looks. A lot of these part numbers, if you see here, this looks a little intimidating. Each part number has a series of letters and numbers, and each letter and number signifies a different type of specification. For example, the first spot here designates which frame size we're using. A 5 in this case is listed right here, a 90 millimeter square frame, or 3.5 inches, 3.54 inches. I, which is a lot of times misinterpreted for a 1, stands for induction motor. What we'll see later is this letter will change to an R for reversible motors and so on. The third selection here, K, this stands for K-series motor, the global K-series motor. The next spot, the 4th position, is then going to be the different types of wattage. Again, if you remember, I said we have 1 to 200 watt motors. So if this was a 1 watt motor, it would say, 1 GN or something like that afterwards. Speaking of GN, the 5th position here, GN stands for the type of pinion shaft we have. Now with the pinion shaft, we have 2 different ways with our motors. We have round shaft and pinion shaft. Now if we look at the actual motor of these 2 different series, what you'll see here, I have a couple ready for you. This here is our 3 different motors. This one selected here is our round shaft type motor. This one is a cutaway that we have made with a motor with a gear head on it. And this is the motor without any gear head, and it has a pinion shaft on it. The round shaft type motor, when we look at this, has exactly that. It's completely round. It has a flat on one side, which I know is a little difficult to see, but there is a flat here. Other than that, the shaft is completely round. The gear head type, depending on the size, may also have a flat, or it may have a key weight to it. So here we can see the different types of how the gear head is put together. Basically, this is one whole unit that can be removed and then put onto a different motor, or a different gear head can be used. If you notice on this, there is a helical cut, or often called a spur cut, on the pinion shaft. This allows for the gear head to be meshed on top of the motor. So if you have a round shaft type motor and then the application changes and you now need to have either more torque or less speed or something of that nature, and you have a round shaft type motor, what's going to end up happening is you're going to have to purchase a new motor that has a pinion shaft on it to match it with the gear head. Since there's no helical cut or spur cut on this, it requires a new gear head. Okay, and moving along, we're at position 6 in our part number. 6 stands for the different voltages we have available. As we said, we can do different voltages to help throughout different parts of the world. We have single phase 110, 115 options, single phase 200, 220 volt options, and we also have a 3-phase 220, 230 volt option. 2 in the position 7 stands for RoHS compliance. For those of you that don't know, RoHS compliance is a European safety version that is now becoming more popular as more companies and more customers are becoming more global conscientious. What this stands for is that the product that was used to make it, including the paint, the wiring, nothing has hazardous chemicals or hazardous products to you, your employees, or the environment that they're in. Everything is environmentally friendly. The other thing that it stands for is RoHS compliance. We've also used a different type of bearing compared to what we had before, and now our motors are rated for 10,000 hours. Our non-RoHS type are only rated for 5,000 hours. So moving on to position 8. T stands for terminal box. In some cases we also do have conduit boxes available and then just plain flying lead wires available. Up until this portion, positions 1 through 8, these parts of the part number are usually listed right on the motor. So a lot of times if you're looking for a replacement of the motor, this will be the only thing written on the motor, when in fact we will add the letter U or E at the end. What this signifies is that the capacitor is included. Capacitors are required for all single-phase motors. A 3-phase motor will not require a capacitor. And this will just be done to help, 1, with your lead time, and 2, it's always good to use a fresh capacitor with a fresh motor. Then looking at our gearhead options. Gearhead's part number structure is almost exactly the same. Position 1 stands for the frame size. We have the same frame size of the gearhead as we do of the motor, 90mm frame. GN stands for the style of the pinion. So all GN motors have to go with the GN gearhead. So the 2 things you need to look for is, 1, does the first number, the 5, match with the first number of the motor, a 5. If it does, let's move on to the second portion of GN. If GN exists in the gearhead part number, we need to make sure that GN exists in the motor part number. The third position here stands for our gear ratio. We have a lot of different gear ratios available. From small 3.6 to 1 up to 360 to 1 different gear ratios. SA in the part number stands for the long life, the low noise for the RoHS compliance, so that 10,000 hour life rating. More specifically, the A part of this part number stands for the USA version or the Imperial version. So the output shaft of that gearhead will be measured in inches as opposed to millimeters. If you ever come across a motor that does not have the A, so this is no longer written and it just comes to 5GN50S, that would stand for a metric style. So the output shaft would then be measured in millimeters. Moving along, we have a different motor part number structure here. Again, the same type of thing works for this. Different parts of the part number, or different letters and numbers of the part number, mean something. If we take what we just talked about before, 1 signifies for the BH series, I stands for induction motor. 6 will stand for the frame size, which in this case is 104 millimeters. The 2 examples for the output power, or the wattage again, in this case a 200 watt. F in this case stands for single phase 110, 115 voltage, and the T stands for that a terminal block is used. We also then move and combine that motor with the same gearhead part number of a 100, which means 100 to 1 gear ratio that's being used. So that'll give you a lot of higher end torque and low end speed. RH, we have a couple of different things that are available for RH. We have right angle hollow shaft and right angle solid shaft gearheads available. These gearheads can do multiple different things as far as mounting and orientation. And also the nice thing about the hollow shaft motor is it can be used as a through hole. Now I have a motor here. We'll show on this side. This is our BH series motor. If you see, compared to the smaller induction motor, it's much bigger for a 200 watt motor. This is going to have the BH series part number here, so the motor has its own part number, and the gearhead here will have its own part number. It has the terminal box on it. Now if we look here, we see here is the flat hollow shaft. There is a keyway inside the hollow shaft. For some reason, if your application calls for a through hole, or you're multiplying different conveyors that are going to be used at the same time, you can turn to the side, and we have a small, like Phillips head screwdriver would take out this screw here and this screw here. This cover would then come off, and you would then be able to have a full through hole for your gearhead. When not in use for that, I recommend that you keep that on. That way it helps keep any type of debris or dirt out of that. We talk about in our catalog a lot about overhung and thrust loads. Thrust loads and overhung loads are important to take into consideration, especially when looking into different types of mounting orientation of the motor. Overhung load is exactly how it sounds. If we take a look at the gearhead that we have here, this amount of overhung load that's displayed in a vertical position. What happens is if we have, for example, let's say a pulley is attached to this, and from that pulley we have a load that comes down on a belt or a cable, and it needs to be raised up. So let's say, for example, this is a 1 kilogram load. As it's going up, we need to make sure that the position of where the overhung load is within specification for this motor. Different gear ratios are going to have different overhung loads, and it also is going to depend on where is it exactly located on the shaft. Is it out towards the edge more, or is it in towards the flange more? Okay. The overhung load is given out in two different types of specifications. If we look here, we're going to see the specifications written here without the parentheses is in pounds, whereas the ones in parentheses is with newtons. Okay, this specific one is saying 0.39 inches from the shaft end. Okay, what that's saying is the further end of the shaft, so the far end of the shaft here, 0.39 inches in, or 10 millimeters in, it can handle up to 22 pounds. If we go further in, 20 millimeters in from the shaft end, so from here in, what we're looking at is 33 pounds or 67 pounds, depending on the gear ratio. The gear ratios for the smaller ones, like a 3-to-1 to an 18-to-1, are going to have smaller overhung loads, whereas the higher 25 to 180-to-1 gear ratios are going to be able to accept higher loads. Then the actual thrust load is the thrust that goes along the horizontal axis, so any thrust that gets pushed into the motor or into the gearhead. So at any time if something's positioning and it knocks continually into the shaft around here or off to the sides of the shaft, anywhere that pushes inward, they can cause damage to the bearing. It can knock the bearing back and forth. In this case, for 4GN style gearhead, regardless of the gear ratio, the thrust load is going to be around 11 pounds. Any more than that, you can sustain damage to the actual gearhead and the bearings inside. Wiring of our AC induction motors is extremely simple. 3 lead wires, so we have our motor, and then what comes off is the black lead wire, which will then go to our line voltage in. And then we have 2 lead wires that will be connected to our capacitor. Our capacitor is going to have usually 4 different prongs on it available. The 4 prongs are going to be tied internally. If we take a look, I do have a capacitor here that we do supply. This is for our larger series motor. Now this capacitor, as we look at it, is going to have 4 prongs, 1 here, 2 here, and 2 here. These 2 that are closest together are tied internally. These 2 are tied internally as well too. So for our motor, we would have the lead wires come out. The black lead wire would go to the motor, or from the motor to the line voltage in. We would then put a red wire here and a white wire here. Depending on the rotation needed, you would then take the neutral line from your power supply and either put it to the red or the white, depending on the direction that you needed to have. Red would give a, in this case with this example, red would give a clockwise rotation, whereas white would give a counterclockwise rotation. Okay. A standard switch that you can get in most hardware stores or any type of electrical supply stores that you've used before, any type of those will be able to help change the directions. We also offer the V series of the motor. The V series is very similar to the World K series. It has a higher strength, longer life, and more quiet gear head combination during operation. Now the V series advantage is pretty easy to see. What we're looking at, the larger gears in the bearing and the GV style gear heads allow for a higher permissible torque because the teeth on the gears won't break off until higher forces are seen. So if we take a look at this chart here, down here on the x-axis we have our gear ratio. On the y we're looking at permissible torque. Okay, so if we look at, let's say for example, a 100-to-1 gear ratio. A 100-to-1 gear ratio on the GN style, you're looking at around 10 Newton meters of torque. With the larger bearing, the larger teeth, with the V series at a 100-to-1 gear ratio, you're looking at around 25 Newton meters of torque. So we've doubled, basically, we've more than doubled, about 1.5 times the amount of torque that can generate with the V series gear head. Higher maximum torque up to around 3 times of that as we start to look into the higher gear ratios. Part number structure of the V series is almost identical to the exact part number structure as the K series. Again, everything is going to mean something in this. We can take a look at this very quickly. The V series for position 1. 2 stands for high power. This is where it changes up a little bit. Before we were looking at I, and this specific one we're looking at R, which is a reversible motor. Again, same thing. For the 5 is the frame size. 40 would be our wattage. A would be for our voltage available. 2 would be the RoHS compliance. In this specific part number, we included an M, which stands for an electromagnetic brake. Our electromagnetic brakes are a power-off type, so when there's no power going to the motor, the electromagnetic brake will stay on. This is designed to help for safety in any type of power outages or anything like that. If anything's suspended in the air and the power goes out, we don't want anything to fall and hurt anybody. The dash 100U. 100 is going to be the same type of thing. It's going to stand for our gear head ratio. With like the BHI series, we saw that as well too. This comes as one assembly. U as well is going to signify that the capacitor comes with the motor. Again, capacitors are only needed for single phase, AC motor and reversible motor options. The reversible motor is available in both, or I should say, between 1 and 90 watt motors. They're bidirectional, so they can switch on the fly. There's no stopping, like on the AC induction motors. The reduced stopping time of 5 to 6 revolutions per minute, and this is because of a brake shoe that's involved inside the motor, which we're going to go over. Limited duty cycle. This is different from the AC induction motor in the aspect of the AC induction motors could run continuously all day and all night. The reversible motors are limited to a 30-minute duty cycle. So if they're on for 30 minutes, they will need to be off for 30 minutes. And because of that, we have the difference in adding the brake plate and brake shoes on the back of the motor. So if this is our motor, we look at the cutaway here. We have our brake shoe listed here coming in. The spring, which is right behind the actual brake shoe. And then we have the brake plate in here. Okay. When the power is removed from the motor, the friction on the brake plate brings the motor to a stop with that added friction, and that's how we achieve the 5 to 6 revolutions of overrun. Reversible motors are ideal for like copiers, x-ray equipment, packaging equipment, or ticket vending machines, that type of thing. Again, looking at the basic 5R K series or the GM, the World K series part number structure, very similar to the same thing as before. 5 indicating the frame size, R indicating reversible, K which series it is, and everything remains to be the same between the gear heads and the motors. If we look at system configuration, what's available here is basically the basic system of our motors. It's going to include the actual motor and gear head right here, along with the capacitor that's going to be required, and it will come with your motor. The AC power supply is not supplied by us. That would depend on like coming from your wall outlet or some other type of power supply. These components that you see here written around are different added benefits or added accessories that can be used. Like in this specific one, we have an SB50 brake pack, which is designed to stop the brake instantaneously. Okay, we also have mounting brackets available for use. We also have flexible couplings in various different sizes. Again, as you saw, we have the the right angle gear head and solid gear heads, solid shaft gear heads. And we also have available linear heads for both vertical and horizontal applications. Wiring for this reversible motors is the exact same it is for the induction motors. 3 lead wires. The wiring is completely the same as far as lead color structure. Still will need to use the capacitor, and we'll use a standard SPDT switch to change the direction. And this can be done on the fly, so no stopping will have to be done prior to switching direction. Synchronous motors. These are another motor that we have available. They're rated for continuous duty, fixed speed of 1800 RPM at 60 Hertz. Different gear heads are available. Reduced torque, and again, watch for the overrun. It would be around 30 to 40 revolutions of overrun, just like our regular AC motors. Now, the difference with the synchronous motor, if we take a look here, 4 notches are made into the rotor lamination of the synchronous motor. These extra notches are filled with the molten aluminum, so it's the same process of making the AC induction motor. We're still skewing the plates, but we're also adding 4 extra notches. This creates an area that has higher reluctance in the areas between the notches. So this is a induction motor plate here. This is the standard one that we looked at before, and it's slightly skewed when we pour the molten aluminum down. This one down here, we have the 4 notches located right around here, here, and here. So in these notches, we're going to pour the molten aluminum down there. So these 4 interacts with the 4-pole stator, and the style of the motor runs with no slip. So when the motor, the rotor runs at synchronous speed of around 1800 RPM, it's going to maintain the current. It's going to stay in tune with the interaction of the 4-pole stator and the magnetic current going around. The drawback to the synchronous motor is that they only have about 30 revolutions. They have about 30 revolutions of overrun when the power is removed. Since it's focused down only 4 bars, a reduction in torque is seen because of this. So if we look here, we have our speed on the X and the torque on the Y. We maintain our torque at our speed, and then at a certain speed, usually due to either gear head efficiency or with the round shaft type motor, it just drops off. This is where the maximum or the most efficiency of the motor is. Synchronous motor applications are most commonly used in fax machines, electrocardiograms, for that, different types of heart monitoring machines, constant flow pumps, optical character recognition, and magnetic ink cartridges. Synchronous part numbers, synchronous motor part numbers are the exact same type of structure as with the regular ones. Each part, again, will mean something. Frame size followed by series, wattage, pinion shaft, voltage, and in this specific case here, the UL stands for our UL rating, and then A is that the output shaft type. And then again, same thing with the gearhead part number. Frame size, along with pinion style, gear ratio, output shaft. Whether metric or imperial. Configuration is the same as before with the AC induction motors and reversible motors. Mounting brackets, couplings, and right angle gearheads are available. The torque motors. The torque motors that we have are always used for similar applications. Tensioning or winding, or like a take-up reel. Has a full speed range. It's designed to be stalled. Tensioning or back-driven applications. The duty cycle is limited depending on the application that's being done. Torque drops as the voltage will drop. Now here, when we look at the motor rotors, we see the torque motor is a very specialized motor in that it has a high slip rotor. Our other AC motors have a low slip rotor. What this means is that when the rotors rotate very closely behind the rotating magnetic field. So the high slip rotor is made of one solid piece. So if we take a look at right here at the high torque, or the torque motor, we don't see any lines that come across the rotor itself, unlike the induction motor. Okay, that's because it's just one solid piece of metal with no conducting bars. The induced current flows over the surfaces of the rotor, allowing to have a slip of 100%, or slip is also known as stall, or even be able to do back-driven. Because the torque motors can be stalled or back-driven, they have no unstable region. They can be operated anywhere between 0 speed and near synchronous speed, and still be able to maintain torque. Different types of applications for torque motors. Tensioning, as we talked about, take-up reels, postal banding, winding applications, and labeling systems. Part number structure, again, is very close to the same. Again, we're looking at frame size. T in this case is going to be the torque motor. K for the series, wattage, pinion shaft, voltage, RoHS compliance, and then capacitor. Gearhead part number structure is exactly the same as the rest. Frame size, pinion shaft, gear ratio, and then output shaft of the gearhead. Configuration is also available for these. Unfortunately, right angle shafts or hollow shafts and solid shafts are not available for the torque motors. Mounting brackets and couplings, however, are available. Extending off of the TMP, we do offer a controller, which is a torque controller. Single phase 100-230 volt option, requires a 24 volt DC supply. Easy torque adjustment. It switches between two torque levels. It has instantaneous bidirectional operation, both syncing and sourcing, and around a 10% variance on the torque. So it allows for easy adjustment of the torque. It can be used with the different voltages. The external voltage is required for the TMP. So what we're doing is we're actually changing the voltage to the motor to change the torque. As we talked about, voltage and torque are proportional. At a certain voltage without the motor, or without the controller, if you were to take a torque motor and just run it at a 110, 115 voltage, you'd have around a 5-minute duty cycle rating. This is because of added heat to the motor. If you were to drop that to around 60 volts, this would be able to run continuously then. What we're doing with the TMP control unit is we're taking the voltage to the motor and decreasing the torque or increasing the torque depending on your application. For a winding application, this would be ideal. For you're going to need larger torque when the roll is bigger as opposed to when the roll is smaller. We're not changing the speed, we're just changing the torque. So what we're essentially doing is changing the torque speed curve. We're maintaining the same speed but varying the torque at different speeds available to that. Watertight induction motors. What we have here is an IP67 rated motor. This motor is capable of handling different types of washdown and anti-corrosive areas. I do have another motor here. Let me show you. This here is the FPW series. Now, the FPW series, as we said, is it's a different paint job that's on there. You do notice it's got the white painting as opposed to the flat black or the gray that's on there. The motor itself is going to have an IP67 rating as a stainless steel shaft and a non-porous aluminum case. Special powder coating, which is with the white that you see here, and it has rubber seals around the O-rings and inside the shaft here. This is going to have an O-ring right inside, so that way no water or moisture can go in through the shaft, and as it's coming across the top, no moisture will get in between the gear head and the actual motor casing itself. The actual cable construction, instead of just a flying lead wire, we did change this to have an actual sealed connector on top of it, and then the lead wires will come out about 16 inches away from the motor, and then different types of accessories can help extend that cable and protect that connection. The watertight motor part number structure is the exact same as it was before with the other types of series. FPW standing for the FPW series. Frame size, wattage, voltage, RoHS compliance, gear head, and capacitor. Please note that with the watertight series, the motor itself is able to handle different types of splashdown and everything like that. The actual connection does not, so we do offer like a terminal or IP67 conjunction box that you can input the extension cable or anything like that through. The other thing to note too is that the gear head that comes on here, like in this case for this part number here, like position 6, says it's a 15:1. For some reason, if later on in your application you then needed to go to a 20:1 gear ratio, unfortunately the gear head cannot be purchased separately. Because of the IP67 rated seal, if we were to take the gear head off, it would break the seal, thus losing the safety, or excuse me, the IP rating. So if the application changes to where a different gear or torque value are needed, you will have to purchase a new motor as well. System configuration. This here is the power relay or the junction box that we talked about. What would happen is the cable would come in through one end here. You would have your actual soldered connections or terminal connections inside, and then coming back out to the opposite side to your power supply. Capacitor would come with this as well too. We do offer the extension cables, which would then connect to the junction box if needed. So the motor would come out with its 16-inch lead wires, connect to the junction inside here, then go back out towards your power supply. The EMAG brake motors that we have available are a power off type. As we talked about before, they're available for constant braking force, holding torque, and the duty cycle, however, is limited as well too. The electromagnetic brake has an extended shaft on the back of the motor where the brake is placed on a hub. So if we take a look, this is the back end of the motor here. Now typically this is just where it would stop. But with this hub that we've used, we've extended the shaft out. And when power is applied to the brake leads, which come out here, the coils act as an electromagnetic and pulls the armature away from the brake hub. The motor will spin if power is applied to the motor leads. When the power is removed simultaneously from the motor leads to the brake leads, there's no longer any current flowing through the magnetic coil, so the spring will force the armature into the brake hub, causing the load to be held in a position. Okay, so when the power is removed, the load goes right into just a stop condition or holds on to it. Power to the motor should mostly only be applied while the brake is engaged, and this will wear the premature or allow for premature failure. So if you have the brake on and you apply power, it's just like doing like a brake torque in your car. You're going to spin your tires and wear out the tires quicker. The same concept applies to the brake hub and the armature here. In this picture, it's a little difficult to see. It takes a really good eye, but if you look, when the magnetic brake is disengaged here compared to when it's engaged, there's a real thin area right in here. There's a little gap, so when it's disengaged, the gap is open. When the brake is engaged, if you look back in the same area, the gap is now gone. So this is when the armature and the spring are pushed against inside the brake hub. Part number structure for our electromagnetic brakes is just the same as it was before for the rest of them. I'm sure by now you're starting to finally see a pattern in it. Frame size, reversible, K-series, wattage, pinion shaft, voltage, RoHS compliance. We added one more component in here, the M for the brake, U for the capacitor. The actual gear head part number structure, again, has remained the same. The BHI series, also available in an electromagnetic brake version before. Again, with same part number structure, except we added the 6 in the 6th position here, the M for the electromagnetic brake. System configuration, very similar to everything else. We have our AC motor that's connected to the capacitor, connected to the power supply. Different gear heads are available, the right angle, solid, and hollow shaft, along with linear gear heads. The brake pack is also available. Again, this is for instantaneous stopping, so if you were to use the electromagnetic brake to hold the load, but you wanted to stop the motor quickly, what the SB50 did is basically it takes the current away from the motor to help it stop instantaneously. Then your electromagnetic brake would turn on, and then you can hold the load in the air or depending on where the position is. Flexible coupling is also available for this type of series, and different mounting brackets are available. Clutch brake. This series that we have here is excellent for high cycling applications. It's attached to an induction motor, and it's rated for continuous duty. So unlike the electromagnetic brake motor that had a reversible motor on it with that 30-minute duty cycle rating, the clutch brake motors are capable of continuous duty here. We're looking at around 100 cycles per minute, so start and stop, so engage and disengage of the clutch brake about 100 times per minute. The motor is always spinning, so the same concept, clutch brake, is just like in your car. If you ever drove a stick shift car before, when you engage the clutch, the engine still continues to spin, but you get no rotation out of the tires. Same concept here. The motor's constantly spinning, the clutch just disengaged the rotor from the gear head, and then will continue back on once it's re-engaged. It's rated for a 2 million cycle rating. We have a small clutch brake pack system with numerous gearboxes, and with the clutch brake, less than 1 revolution of overrun. Again, this is looking at the same type of breakdown, just an internal. The motor shaft is always spinning. However, the output shaft of the gear will only spin when 24 volts DC is applied to the clutch. Now for the brake, the motor shaft is always spinning, but the output shaft of the gearbox of the gear will brake when 24 volt DC is applied to the brake. Since the motor's spinning, we don't have to worry about inrush current problems, such as multiple machines off of one power outlet or one power source. No inrush is going to be an issue because the motor itself, the rotor, is still spinning. This is why it's good for higher applications or higher cycling applications. This is a picture of our clutch brake series motor here. This is a larger size motor, so if we do compare this to like our basic AC induction motor or a motor with an electromagnetic brake on it. So I do have another set of motors here. And if we take a look here, we'll see, again, keeping reference to our AC gear motor without a gear head on it, that's here. This is our electromagnetic brake type motor. So as you can see, this around here is where the actual motor case stops. and then this is where the brake hub is. Now, if we take this same consideration, we have the same size motor. Here's the clutch assembly, and then here is the brake, or excuse me, the gearhead assembly. So the clutch brake is here, the motor is here, and the gearhead is on top. It's important to know that for any reason, if something were to come damage to the actual clutch brake or to the motor itself, it would require that this series, this whole package here of the clutch brake and the motor would have to be purchased together. This is a quality issue. What we do is each time we assemble or make a clutch brake series, we test and assemble it mated to the motor. This ensures that throughout all the testing processes, this assembly was guaranteed to work for you or for your customers. The gearheads are interchangeable. We can change different types of gearing on here. This specific one has a 9-to-1 gear ratio. We could change this to a 15-to-1 or a 20-to-1, and all you would have to purchase would be the gearhead itself. Clutch brake applications examples. What we have is a fluid injection system. Very common for this type of a thing in the medical application field. With the clutch brake, it can disengage and re-engage smoothly without having any massive jerking or inrush current, as we talked about before. So these test tubes would be able to move along in this direction here, and then as it's moving, they would be able to stop, disengage, and re-engage to have the tubes filled up. We have the clutch brake. If you look here, we do have the wiring example of it. 4 lead wires would come out of the motor, 2 orange and 2 blue. 24-volt DC is then applied to our circuitry for the clutch brake motor to allow it to engage and disengage. The CBI part number, or the clutch brake motor, the part number breakdown is very similar to where everything else was. CB standing for the clutch brake series. I standing for induction motor. 5 would be the frame size. 40 is the wattage. The 7th, right here in the 5th position, stands for the pinion shaft type. Before we were using GN and GU, 7 stands for the type of pinion shaft. So we have a GC, as you see here, and a GCH. These are going to change depending on the size of the motor, or the wattage of the motor. The 6th position here is the power supply voltage, or excuse me, it's the clutch brake type. The 7th position here, the 1W, is the power supply voltage. U stands for the capacitor. And again, same basic part number structure for the gearhead, however, we just changed GC instead of GN or GU or anything like that. System configuration, same as it was before. The motor is connected to a capacitor, which is then connected to the power supply. Flexible couplings are available for this for an additional purchase in case you're coupling to a different type of shaft, pulley, or different type of external gearing. Looking at different types of accessories available. Again, the SV50 brake pack, available for the instantaneous stopping, both forward and reverse, that are available. Electromagnetic brake control, so there is an actual wiring designation for if you're using the electromagnetic brake motors. Thermal protector open detection, so it knows what to do when the thermal protector switch turns on in the case of higher heat. Has the long life rating, real simple wiring. Maintenance free, this is extremely nice. There's no type of program that has to be done. You don't need to cycle out any components or anything like that. Available in the 102.30 volt AC, 50-60 hertz, and it works for the 1 watt motor up to the 90 watt. So the 1, the 6, the 15, and going on all the way up to the 90 watt motor, this brake pack will work for it. Again, as we talked about, we have different right angle hollow shaft gears available, right angle solid shaft gear heads available, different couplings, mounting brackets, external potentiometers are available. So, for example, using the TMP, the external control for the torque motor, there's an onboard potentiometer for that TMP there. However, if you were using this for some type of board control unit or controller panel away from the actual electrical panel, you can purchase an external potentiometer. Electronic speed indicators are available to be purchased as well too, telling you what the actual speed of the motor is or the motor after with the gearbox. The power relay box, we talked about this as well too, the FPW series. This is the IP67 rated relay box to allow for the connections to stage Y if you're using any type of extension cables for the FPW series. Just briefly want to talk about the overrun real quick. The stopping accuracy of our motors is usually important to customers, especially when doing different types of indexing moves or wind-up applications. So induction motors, as we talked about, 30 to 40 revolutions of overrun, continuous duty cycle. Remember that the overrun is with no gearhead and with no load on it. Reversible motors, 5 to 6 revolutions of overrun. That's because of that brake shoe and the friction braking on the back. 30-minute duty cycle rating. Electromagnetic brake motors, 2 to 3 revolutions of overrun. Again with a 30-minute duty cycle rating because they utilize the reversible motor. The brake pack, 1 to 1.5 revolutions of overrun. Clutch brake, 1 revolution or less, but rated for continuous duty. The gearhead backlash on all of our gearheads is typically the same of 1 to 2 degrees. So to also keep that in mind of any type of gearhead that's being used, so if you have 30 to 40 revolutions of overrun, but you're using a 100 to 1 gear ratio, it's possible you may not really even see much overrun on the output shaft side of the motor. Well, with that, that's pretty much everything that we have to offer for our AC motors. We have other seminars coming up throughout the year, throughout the different months. Hope to see you all there. I'll open it at this time if anybody has any questions. Okay, well, I want to thank everybody for sharing their time with us this morning. If you have any questions, feel free to contact us at this phone number here, the 800-468-3982. Our tech support is here from 7:30 a.m. Central Standard Time until 5 p.m. Pacific Standard Time. We have 2 offices located in Chicago and outside of Chicago and Elk Grove, and then we have another office in Torrance, which is located right outside of Los Angeles. Feel free to call either one of these phone numbers if you have any questions about the products that we talked about here today or any other products. We'd be more than happy to help you out. And with that, I'd like to thank you again for your time, and everybody have a good 4th of July. Thank you very much.